In this video, we're going to talk about practical skills and specifically the separating funnel and the drying. And we'll touch on distillation and an exam style question at the end. So let's go back to our plan that we've had throughout our practical skills videos. Remember, first of all, you synthesize, okay, and then you sometimes, not always, do some form of purification. That purification is done in two ways: recrystallization or distillation. But before that, sometimes you have an aqueous and an organic mixture and you need to separate them. And that separating is done using a separating funnel. So after you've done that, often you can follow this by distillation, or sometimes even you can follow it by recrystallization. But most of the time it's going to be doing the separating funnel followed by some distillation just to really purify the product. But let's go through some examples of that and hopefully make a bit more sense. So the purification is done using the separating funnel, and the separating funnel allows you to do separation within the lab, okay, of aqueous and organic mixtures. So the aqueous and organic mixtures have different densities, okay, and it's typically where an acid is added in your reaction. So sometimes acid is added in the reaction. You need to neutralize that acid. So using a separating funnel to create an aqueous and organic mixture is often done because you've neutralized what is in the actual reaction mixture. So for example, if there's acid in the reaction mixture, you would neutralize it with some aqueous alkali, and that would then give you an organic and an aqueous layer. Now, typically the reactions where this happens, which have happened in exams before, is nucleophilic substitution. So nucleophilic substitution, normally you can take an alcohol, sulfuric acid and a sodium halide, and that turns it into a haloalkane. Now my point being here is just look, you've got sulfuric acid. If you've got sulfuric acid, purifying it will need some form of separating funnel where you neutralize the sulfuric acid. Okay, it can also happen in dehydration. So dehydration has an acid catalyst added to it. So therefore, you would need to neutralize the acid catalyst before you can properly purify whatever the product is. But to show you how this actually works, I'm going to take you into the lab and I can show you an actual separating funnel in action. So in this lab video, we're going to talk about purification and specifically a separating funnel and a drying agent. Now, as a former organic chemist before I became a teacher, I've done this thousands of times, and it relies on some very simple, elegant chemistry to make sure that you can separate out your product from your reactants. So let's look at a reaction where you use a separating funnel and a drying agent. Now, the one we've got is 2-methyl-propan-2-ol, and that is then going to go to 2-chloro-2-methyl-propane. And we do this through using concentrated hydrochloric acid. The concentrated hydrochloric acid is aqueous, and your product is a carbon compound and is organic. So anything that's carbon containing is an organic layer. Now, that organic layer is usually not soluble with the aqueous layer most of the time, and therefore you can separate them using a separating funnel. So the reaction we're going to do is in this conical flask, and the hydrochloric acid and the 2-methyl-propan-2-ol are already in here. We also have this weak base here, which is sodium hydrogen carbonate. So imagine we've got all our hydrochloric acid in here with our product, which is 2-chloro-2-methyl-propane. And we need to get the hydrochloric acid away from it. Well, first of all, we don't want to be dealing with concentrated acid. So we add that weak base that we've got here, the sodium hydrogen carbonate, in, and hopefully you should know what you're going to see, because this is a weak base, this is an acid. What happens when you add a weak base to an acid? Well, you get salt plus water plus carbon dioxide, which is why you see bubbles. Okay, that's all your carbon dioxide going off. And that means if I keep adding the sodium hydrogen carbonate until all the bubbles are gone, I know that all of my acid is neutralized. Okay, and I've done this neutralization reaction. We then take the reaction mixture that I've got here and we place it into a separating funnel. Now this way of doing things can be done in any reaction really where you have acid or you have too much base. So if you're adding excess acid excess base. You may add to the acid a weak base to neutralise it. To the base, you might add a weak acid to neutralise it. But either way, you can do that in this separating funnel. So we've already added that weak base here, and we've got it in our separating funnel. So if you look very closely, you can see that there are two layers. There's a layer at the top, and there's a larger aqueous layer at the bottom. That's because the aqueous layer has a larger density than the organic layer. You know that hopefully because the aqueous layer has hydrogen bonding, which means the particles are closer together, and therefore you have more dense layer, aqueous, at the bottom. So what we then do is we just separate it by using the fact that the aqueous layer is more dense. And we just start letting the aqueous layer out. And you can see this going down the tube. And as it goes down the tube, it's getting closer and closer to the end. And now we have to slow up. Slow, 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 and then get the layers. Oh, there we go. That means we've collected our aqueous layer, which is here. A little bit of drippage there. And we've got our organic layer, which is in here. Now, I am not, and you are not, and anyone's not, going to be able to stop that absolutely perfectly. You will get a tiny bit of water left in your organic layer. So the next stage we have to do is take our mostly organic layer here with our tiny bit of water in it, and we have to dry it and remove the water. We're now going to move on to the drying stage, where we remove that tiny bit of water that is left over in our separating funnel, because remember, it is impossible to separate out all of the water and the product, and you always leave a tiny bit of water in there because you don't want to lose the organic product. So we know there's a tiny bit of water left in our product here. And what we have to do is bond that water datively to a drying agent. So the drying agent we've got is sodium sulfate, and this is anhydrous, which means it's not bonded to water. We then take that, we place it in with our product, and then it will bond with any excess water and create the hydrated product. So here we have, in our equation, sodium sulfate plus that water going to our hydrated sodium sulfate. And it's this hydrated sodium sulfate that we can remove by filtering, or we can decant our product away from because it's a solid and our product is an oil. Let's actually do it. So we take our conical flask, we just collect our product from the separating funnel, and then we take a spatula and put our drying agent, sodium sulfate, in. And there are many types of drying agent. You can have sodium sulfate, magnesium sulfate, calcium chloride. I'd recommend just remember one. Okay, and then you swirl it. Now I know this definitely takes 2 to work, but you would add a little bit at a time until it fully dried. Now you know it's fully dried because when you look at it, you can see the solid moving. The solid clumps together when it's bonded to the water. When it's no longer bonding to the water, it moves when you swirl it like this. And if it moves and it's not bonding to water, that means there's no water around, which means it's fully dry, and hence this is called drying. Now what we can actually do then is just take this, decant off the product, or we can put it through a filter device to finally get our pure product. And in exams, they like you to just finish off with one final point, is because it's an oil, distill it at its boiling temperature. So if you're given that boiling temperature, distill it at that boiling temperature, and that will finally get you a very, very pure product. But we're going to go back to the studio now, where we'll show you how this is done in the form of an exam style question. So you've now been in the lab and you've seen purification via the separating funnel and then followed by the drying. Now just to go over, the separating funnel is used to neutralise the acid in that case, and often acid, but it could easily be neutralising a base with a weak acid, okay? And that gives you that organic and aqueous layer. Now we've put our organic and aqueous layer here, and that might be indicated by them having different densities, and they are immiscible. So you can literally see the one with the highest density is at the bottom, lowest density at the top. And the bottom one is going to be the aqueous layer because water has hydrogen bonding. Because water has hydrogen bonding, it's usually more dense than the organic, because organic will have less stronger or less or not at all hydrogen bonding. Okay, so your aqueous layer normally comes out at the bottom. And that separating funnel is used to separate those immiscible layers, and densities may be given indicating that you should be using a separating funnel, can sometimes be an indicator. Now we've been in the lab and we can see the use of a separating funnel followed by drying. Let's apply it to an exam style question, a level of response exam style question, which is very, very likely to turn up. We've got a reaction where we are dehydrating hexane 1-ol, so you see over here, dehydrating hexane 1-ol to make an alkene, which is hexene, and we're given the mass of the hexene that we produce. Big talking point here, we've got acid in here, and we're told that it's an aqueous and organic layer, so therefore your brain should be saying separating funnel. Okay, and then you've got an expected percentage yield of 40%, and it's asking you to calculate the mass of hexane 1-ol you started with. So we've got two big parts to do. We've got to do the mass of that hexane 1-ol, and we've got to explain how the pure hexene could be obtained. And we're also given some data. So if we're given some boiling point data, it's kind of saying to us we should do some distillation at the end. So let's put this to the side. Put the equation, the simplest equation, we can put it in a molecular formula here, and you can see that it's going from there to there. I haven't included the water that's kicked out because I just want you to see that it's a 1-to-1. It's not a full equation. But it's just showing that it's a 1-to-1 relationship with those two. In the exam, you will be given it. It's just we're limited in space here. So the other thing is, throughout the entire thing, you'll be using moles equals mass over mR. And you'll be rearranging that. For example, mass is equal to mole times mR. So let's get on with the calculation. So the first step is to do the yield. So remember, you have to do every single step, otherwise you won't get the marks. So don't miss out anything on an LOR. So the first thing is we're given a mass of the hexene. So we're given a mass of this hexene that's here. Okay, so let's make sure that we can work out the number of moles of that hexene. So N in mole, okay, and this is of our hexene, okay, is going to be equal to 5.04 grams, which is our mass, divided by our molecular mass. Okay, and there we have our number of moles to start with. Now that is equal to 0.06. And so that is our number of moles for the hexene. Now remember, this is at 40%. So this is 40% of what I should have produced. It's a 1-to-1 ratio. So I need to get this number of moles back up to 100%. And that would be the 100%, if it was 100% yield, how many moles of this I would make, and therefore how many moles of this it would come from. So we need to convert that back up to 100%. So, and that 100% will be the moles of this that we could have made, which would be the number of moles of the hexane 1-ol. So essentially, the number of moles of the hexane 1-ol, okay, is going to be equal to 0.06. Remember, that's the 40%. Okay, which is going to be divided by 40 and times by 100. If we divide it by 40 and times by 100, you're going to get 0.15 mole. So we've got 0.15 mole of that. So we now need to turn that into a mass. So mass is going to be equal to moles times mR. Okay. So we have our mass in grams, okay, and this is of our hexane 1-ol. So that means, we get our blue again, that'll be 0.15 moles, and then that's times by the mR. Now the mR is 102, and the biggest mistake you'll make in all of this is when you're trying to calculate these, because they usually give it to you in skeletal formula and ask you to calculate it. Okay, now if that is the case, that will end up being 15.3 grams. That's a nice number. Okay, so we've done our calculation, we've done the mass of hexane 1-ol that we created. Now let's move on to explain how pure hexene could be formed. So we know we've got an aqueous and organic layer. So if we know we've got an aqueous and organic layer, let's move on to this separating funnel. So our purification will be done, so we'd use a separating funnel. Okay, now, if we're using a separating funnel, okay, that's because we have, and there's important points here, we have aqueous layer, okay, and that aqueous layer is at the bottom. Okay, so the aqueous layer is at the bottom, and that means the organic layer, okay, that organic layer is at the top. Okay, so using the separating funnel, the aqueous layer is at the bottom, the organic layer is at the top. We're going to separate it using that separating funnel. Now, after we've done that, okay, we take the organic layer, and we add drying agent. So we add drying agent to the, okay, organic layer. Okay, so we've added a drying agent to the organic layer, and you've seen how we can do that in the laboratory. So we've done that, okay, and that drying agent, let's give an example, and the example is always an anhydrous salt. So let's do it, an anhydrous salt. It's really important you say anhydrous salt, and then just pick any one of the ones which you can pick. So the one I normally pick, because I used it all the time during my studies, is magnesium sulfate, but you can have calcium chloride, okay, and you can also have sodium sulfate as well. Okay, and that's really small because I'm running out, so there you go, sodium sulfate as well. So we've got, I would stick with that one. Now, if we're going to finish off now, remember we have not used the boiling points at all. We use the densities because we know the organic layer is at the top and the aqueous layer is at the bottom, okay? But what would we do now? Well, we're given the boiling points. Well, let's just redistill it, because the boiling point of hexene versus hexanol is really different. Hexanol is 157. So the last point would be redistill. Okay, and because you're given a table, you've got to put a temperature in. So all you have to do is put a temperature around about your product. So your product is going to be at 63, or boiling point at 63 degrees. So I will redistill at 63 degrees. Okay, I just want to make one thing clear at the end, because I realise how small that is. Okay, and I just want to make that abundantly clear. That is Na2SO4. Okay, so let's just summarise this again. First of all, it's a one-to-one relationship. Okay, we can work out our number of moles of our hexene. So that is our number of moles of our hexene from the question. We then turn that back into 100% because it's a 40% yield, then times it by our molecular mass to find out the mass of hexane-1-ol. Then, because we've got an aqueous and organic layer and the hexene is impure, and because we added an acid, because we've got H3PO4, which is an acid, you can use a separating funnel, and the aqueous layer is at the bottom, the organic layer is at the top. Now, because you've used a separating funnel, you now have an organic layer. You can add a drying agent to the organic layer and use an anhydrous salt. That's magnesium sulfate, calcium chloride, or sodium sulfate. And then because they've given you the boiling point data, redistill at whatever the boiling point of your product is. In this case, it's 63 degrees. And if you can get all those three of those points, you can get 6 marks on this LOR question.